Dr. Satyamurthy and Arun Grover for inviting me. I'll be next 20 minutes or so. I'll be talking about basic science, what science can do for environment sustainability. But it's a really a big subject, so I may not be able to cover all the aspects. So I'll be concentrating only two important issues. One is on air pollution, and another is on heat waves, which we are all vulnerable. And these are 17 SDGs, which we all of us know that. And I'll be talking about air pollution and severe heat waves, which can which can pertain to SDG 11 as well as SDG 13 or so. Air pollution, as you know, that it is the greatest environmental threat to public health globally, and estimated 7 million premature deaths happen every year. And of course, there is a lot of controversy about this number, 7 million. And air pollution and climate change are very much interlinked, and because all the major pollutants have they mostly share the common sources with the greenhouse gases. And so improving air quality will bring more better health and more net development as well as environment benefits. So when we talk about air pollutants, what are the major components? One is a particulate matter, which we normally discuss in cities like Delhi and all, particulate matter, PM 2.5 or PM 10.0, etc. And so 2.5 is nothing but one bin with all PM below 10 micrometer, and 2.5 is nothing but all below 2.5 micrometer. Then of course there are gases like nitrogen oxides and nitrogen dioxide and sulfur dioxide, carbon monoxide, ozone. These are all gases which are basically called air pollutants. These are all due to human activities. And this is so sources of air pollution, especially in cities like Delhi, it's a very controversial. Transport people say that we don't pollute. Agriculture people say that we don't pollute. So who are really polluting? So there are some studies. For example, this is the latest Terry report, which I have put it here. I'll also show the annual report, annual statement. The industry basically the industry is around Delhi, so contributes about 16. And residential areas contribute about 14. The transport is a big chunk, and it produces about 19%. Power sector, it produces a few, about 6 or so. And the DG sets also create some kind of in Delhi, especially DG sets are very common. And agriculture residue, it's a very controversial as well as very important theme for discussion. And construction work, road dust, waste burning, and outside dust coming from cities like places like Sahara and as well as Pakistan and Rajasthan area. And so this is and of course these numbers doesn't vary much, except agriculture. You can see summer it's 15 and post monsoon season is 22, whereas in the winter it is small. But summer more number because of the Rabi season. They burn Rabi season agriculture residue, and 22 is basically from Kharif. And if you really talk about air pollutants, especially particulate matter, we normally talk about big cities like Delhi, Noida, Gurgaon, etc. But if you really see the satellite picture, the whole Indo-Gangetic plains is completely covered by air pollutants, and this is basically a satellite measurements of aerosol optical depth, which sees us right from Pakistan, it's up to West Bengal. The whole area is polluted by air pollution, and there are changes and positive changes occurring there. And so the question is, if sources are there all the months, why we normally see only during winter season? Winter season only the whole discussions, everything. Even Delhi you cannot go; it's completely thick haze, etc. The question is only we see in winter. And why is it not in summer or summer season? That is basically decided by meteorology. So basically what we see is a kind of circulation like this. It's a kind of anti-clockwise, and whereas in the winter season, the post-monsoon season is basically clockwise circulation. So nothing but what happens means the atmosphere become very stable during these months, post-monsoon as well as winter. This is almost like putting a lid over a heating boiled water. And just if you put the lid to the boiled water, the water vapor won't go. Atmosphere exactly behaves like that during winter, and so sources are there throughout the 365 days. But during other seasons, what happens means all the pollutants get away, either through diffusion, the vertical diffusion, then transport outside, and also it precipitates out. So precipitation becomes an important component of sink. So in winter season this doesn't happen. So that's why we normally see the haze, etc., the pollution literally by ice, through ice, because this meteorology plays an important role. Otherwise 365 days the sources are on. So I will move on to that, and this also causes winter fog, and winter fog is very common. And winter fog also is this is the nighttime winter fog, this is the daytime. These are all the latest data from satellites. You can very clearly see that it is not only over the cities, throughout the Indo-Gangetic plains you can see this winter fog. This is also related to the particulate matter, and that means the whole area is having a large component of particulate matter. And another important component last 3-4 years, a lot of discussion, newspapers, etc., is of the agriculture residue burning in Punjab and Haryana. It has become a very big controversy whenever September season starts, when the burning starts. And this is a very beautiful paper by Jadbhai. He is working in NASA lab. This is the green lines are on, it's called vegetation index, you can measure from satellite. And inside boxes are the burning, the counts, the fire counts. Again, you can measure from satellites. This is in 2012 and this is in 2016. So this is in 2003 and this is in 2016. You can see the big changes. First of all, the NDVI has changed a lot, and also the fire counts have changed for the last few years, and that is clearly shown here. You can see the green line is NDVI has changed, and agriculture, this is a rice paddy, the crop output is increasing, and also the fire counts also is increasing. So the Punjab and Haryana people have been putting rice for many years, for last few years, and the output is increasing. Accordingly, the output for fire counts also increasing. The large quantity of crop output comes, so they have to burn a large quantity of residue. And this is very clearly seen in this is all the red dots are basically fire counts, and you can see that whole fire counts can the particulate matter can come to Delhi, Agra, and up to even beyond Agra. And so this Punjab burning is very clearly, it is clearly shown. And now question is, COVID-19 lockdown has created the natural mitigation effort. You don't need anything to operate. We simply kept our activities down, and we stayed back at home, and very clearly seen that this is the optical, this aerosol optical depth for last many years or so, with so-called climatology. And you can see the 2002, and this is the difference. You can see there is a lot of blue, and of course these reds are basically, I was told it's all burning, biomass burning by the villages here. And but over the Indo-Gangetic plain, you can see that the activity is reduced and the number has come down. And if you really see the different cities, and BNG means the BN means Bangalore basically, and Delhi, you can see that PM 2.5 and normal values around 100 microgram per meter cube, and during this COVID period it has come down to below 50. So below 50 is the threshold for critical limit for Indian region. Of course, WHO prescribes 40, but India prescribes 50. So, so COVID-19 lockdown was basically a natural mitigation effort, and we could guess how much we can bring down the air pollutants during this period. So we have some kind of a threshold now. What is the background activity for each component, like the PM 2.5 or NO2 or O3 or CO, SO2, etc. And another important component we discuss is the air pollution health. And this is a paper again by a group of people who studied. In Delhi and all is okay, so there are a lot of other components, but in the interior parts, or especially over villages, the solid burning, solid fuel burning is the main cause for health deterioration. And they have made studies. For example, I think this is the GDP or so, population weighted PM 2.5. You can see the whole Indo-Gangetic plain is positive, and this is the proportion of people using solid fuel. It is very high. Wherever the people who are working using solid fuel, there the PM 2.5 level also has come down. So the raised PM 2.5 level is not only in cities, it is even observed, as I shown here, is observed even in cities, even in small villages, because they use very lot of solid fuel. And this also the same, this also gives the same message. And if you really calculate so-called disability adjusted life year. So they have estimated what could be contribution due to air pollution when compared to tobacco use, and you can see that it's a large number when compared to tobacco use. And you can have a lower respiratory infections, chronic obstructive pulmonary diseases, even heart diseases, stroke, etc. So the numbers are much larger than the tobacco use. So air pollution basically kills people, but the question is how much number. The government is worried about the number. Some people say about 5 million, some people say about 2 million. So the controversy is in these numbers, but qualitatively people all agree air pollution kills people. So and also because of air pollution is a serious threat issue, serious risk factor, we have developed a early warning system in Ministry of Air Sciences for 3-4 years back. And it is operational now. It is exclusively for Delhi and neighborhood. It is developed by an institute at IIT in Pune, and it's working very well. And also it can same model can be used, for example, to estimate how the dust storm is affecting cities like Pune and Bombay. And people are very happy with the forecast. And now Delhi people, they have a commission for Delhi air pollution for Delhi and neighborhood. It's called Delhi NCR, and they are using our forecast for taking decisions. For example, when to shut down the power factories, when to shut down the schools, when to reduce the transport sector, etc. So this is one good example when we gave that forecast for that particular matter. The PM 2.5 level go up. They took decision and they came down. And it was well discussed in a recent report and by CWE's Council for Energy, Environment and Water, and it's an independent body. And so they have published a paper called Improving Air Quality Management Through Forecast, and they very much appreciated our forecast. So these forecasts are very useful for taking decisions. This is one good example how science can be used for taking good decision policy decisions. And so the question is how better you can improve this forecast. So we have given a big project, Ministry of Air Sciences. It's called real-time ambient source apportionment of gases and aerosol for mitigation SAGAM. It will be done by Isan Mohali with help from IIT Pune as well as MD Delhi, and they will be buying a huge instrument. The total cost of this project is almost 6 crore or so. So what is the ultimate aim is to understand the chemistry fingerprinting of the sources, the chemical fingerprinting of all the sources which are present in the atmosphere. And so people are taking actions. Some of the actions is we should have a legal mandate, we should have state versus city level plans, we should have regional coordination mechanism, and integrating source information to prioritize concrete actions. And of course, we need budgeting, we need money, and tracking progress of the actions which we are taking, clearly delineating the responsibility. This is more important because X will say it is Y's job, Y will say Z job. So that is especially in the government sector. And establishing of an institution overseeing the execution, like for example NDMA for disaster management, we need to have a kind of one big institution. And this is a report by UNEP in which it says that how many countries have really started taking actions on this, on different sectors. One is this industry, so 108 countries, and transport is 71. And air quality standards, many countries have these air quality standards now, but there are red numbers. These are all the countries where they have not done anything. So we have to take action on industry, transport, solid waste management, household air pollution, agriculture, and of course we need a good air quality management, which means basically again data and air quality standards. And I will move on to, so this is the air quality data which I thought about. Gagandeep also was mentioning about data. So this is the beautiful initiative taken by UNEP. Now all the whole air quality data are now available online. You can have a mobile app and you can download it, and all the data are freely. So transparent data is available now. Now I will move on to heat waves. Heat wave is, for example, the 2003 European heat wave, because heat wave also is affect our human beings and our health. And 2022 heat wave was one of the best example which we can quote everywhere. And you can say 2003 heat wave, which was one of the worst heat wave we had, and 40,000 people died in a city in countries like France and Germany, where the health sector is too good. So still 40,000 people died. There is one paper by Peter Scott, a very famous paper in Nature, which they have mentioned that this heat wave was mainly due to anthropogenetic human activities. It could not have come mainly because of the natural variability. It was much beyond the natural variability. So climate change and human activities causing this kind of heat waves in our day-to-day life. And this is the 2022 heat wave. This is the satellite picture of the surface of the skin temperature. And you can see the temperature goes even 51, 53, and it is over 53 degree. And what IMD measures is basically 1.2 meter height. It's called air temperature, but surface temperature will be much more warmer. So during this heat wave period 2022, the temperatures are even crossing 52, 53. And this is a 2015 heat wave is also a large heat wave which occurred. And this is the normal frequency, average frequency. Normally the heat waves are seen here, especially in Northwest India and Central India. And another area is this coastal Andhra Pradesh. It's very, very famous. And there are two areas. One is this, and another is the physical mechanism, dynamics, what of physics is. Physics from this heat waves over here, over here are slightly different. So the prediction also will be different. And this is the average total duration over Northwest India as well as over coastal Andhra Pradesh. And there are changes. This is the trends and average frequency trends. You can see that the trends are increasing and frequency is increasing as well as duration, which we can see that it's almost like 60, 67 years of data, and it's well quality control data, which clearly shows that frequency is increasing as well as the total duration of the heat wave. And this is the 2022 heat wave, and this is the actual temperature. This is the anomaly, and which has crossed even Pakistan. So only good relationship between Indo-Pakistan comes only when heat wave comes, and there is no dissimilarity. There's always we will be together, heat wave, and we are good science. As I'm talking about, must saying about science. We know how heat waves are occurring. Our understanding of heat waves are well known, and there is one paper which very clearly showed that it is not a local phenomenon. It is a huge global phenomenon, large scale phenomena. It is affected by a planetary wave called Rossby wave. This is the composite of 12.5 kilometer geopotential height, which clearly shows the presence of a Rossby wave. So this dynamical forcing is well known, and also it is influenced by local factors. And during this period, the whole northwest region was dry. There was not precipitation. Soil was depleted. Not much soil. And which easily you can see this is the soil moisture, and this is the OLR nothing but outgoing long radiation. It's a proxy of rainfall or convection, which shows that it's all positive big number, which shows that the whole area was dry. So the local soil also will play an important role. It will give a kind of feedback to the large scale dynamics, and it will give more sensible heat, etc. And so this is the future. This is a future projection of heat waves, worst heat wave yet to come, and this is the National Climate Change Assessment Report, which you can very clearly see that the heat wave frequency as well as heat wave duration is increasing. And thanks to our efforts, our predictive capability of heat wave is now good, and even short range size time scale up to 7 to 8 days. These are the three best models we have now. And you can very clearly shows that the blue line you can see is called probability of detection. Even up to 5 days, 6 days, the probability detection is good. And even on seasonal time scale, the models are coupled climate models are pretty good in doing kind of a projection. Kind of a scenario rejection. Scenario of seasonal heat wave frequency. These are observation, these are all model projection. You can see that there is a good similarity between even though there are small differences in terms of numbers. And this is what we are talking about so far, the heat waves without a humidity. For example, April heat wave, we did not have enough humidity, dry soil, so dry atmosphere. But there are places where you can experience heat wave with humidity. And you can think of a heat wave with 40 degree and 80 degree plus 80% of humidity, you will be no more. And so now people talk about, especially coastal areas, etc. You can experience that kind of heat waves with humidity, large humidity. And that one parameter which we measure of that kind of heat wave is nothing but wet bulb temperature, which IMD measures every day using the so-called the Stevenson screen. And there is one famous paper which very clearly shows that wet bulb temperature, anything more than 35 degree will be very alarming. It will really affect your health. Now question, you literally will die. So I will now stop it. Now IMD is coming out. So IMD is coming out with a new tool. It is called it's basically called heat index, which is a kind of a parameter which a function of temperature as well as humidity. So now what IMD produces the heat wave indices etc. exclusively on dry bulb temperature. They don't use humidity. Now IMD will be coming out. For example, a temperature of for example 38 degree, but of 65 degree, 65% of humidity, it will be very lethal. So it will be very alarming for this. So this index is going to come now, and impact of heat waves, it has a lot of heat waves. And before I summarize it, I want to make an announcement. We have brought out a new climate change assessment report for the Indian region, which is free of cost. It's downloadable. It has come out 2 years back. It's published by Springer. Please download it, if you can, and especially for young students, it will be very valuable book. This is the conclusion. So I stop here. Thank you very much.
I have a question. This is more for clarity. Lots of companies have come up, startups have come up in this area of air quality monitoring, and I would expect that is very important, useful, business should be thriving. But what has happened globally is that air quality companies, evaluation companies like Turkina, they have stopped this activity. Stopped. And one other company I know has also stopped. Why is that there is a global decline in the air quality business while air quality measurement is of intense interest in countries? I wanted to have your insights.
Yeah, well, of course, the instruments are very costly. For example, what we have put one station, it cost you about 2 crore, everything put together, including this screen, etc. So now people are going for a low cost sensors, which will with 10,000, 20,000, you can have an instrument.
No, I had one set for 3 lakhs.
So it's a very small sensors, but I have my own apprehension because whether the quality will be comparable with an instrument of worth of 2 crore. And when we really start measuring the air quality across the country and do a mapping, and you will have instrument with 2 crore quality measurement, and we will also have measurements with the low cost sensors with the 20,000 or 50,000. So there could be some issues, but that number is increasing in India like anything. And even Ministry of Environment Forest is funding a lot of institutions to buy that kinds of sensors. So probably that these two companies, I don't know these companies, they may be not having enough business. That's what I feel. I don't know, frankly speaking.
So there are two questions from Professor Hegde as well as Rohini.
Sir, I have 2 questions here. One is that you see, you gave quite a few slides about the fuel, natural fuel, wood, etc., burning and adding to the economy. The dilemma is gas is expensive, poor people cannot afford, and naturally available things are free, cheap, or free for all people, just like in Madhyavan. So what is the dilemma? How do you solve this dilemma? Number 1. Number 2, I watched very carefully, in fact I watch your data in the TVs. It's in the north, all the problems are, in the sense that the heat wave, etc., etc. Is it the natural height of Indo-Ganges range low compared to south? Is there something big like that?
Of course, for air pollution, geography plays an important role. Unfortunately, North India is in a very bad, very unfair geographical region. Height topography, I am not very sure. I am not sure.
First question.
First question, what was the question?
Gas cylinder versus wood.
Yeah, well, that of course I cannot comment. This is only the result which has come from the study. The question is, people are trying. We are trying to tell the people don't use solid food. But I'll tell you a philosophical thing. These are the people who are very poor people. They may not be worried about what fuel they are using. What they are worried about whether I can cook today night.
That's what I must.
Today, whether I can cook, I have something to cook. So these are all big issues. I raised that issue to you. I don't have an answer for that.
Rohini?
I have a much less profound question. You showed one plot from a UNEP report where you showed the number of countries which have taken action
Yes,
on
yes.
different issues.
Yes.
I just wanted to know how many points have we as a country taken some action?
We are not doing everything right. We have good management system. We have good
In
monitoring.
many places we are in the red, isn't
We
it?
have many places. Many places.
What is the status of urban heat wave modeling in India and
We are-
various cities?
We are doing. In share sense a kind of a forecasting system for urban heat waves.
Are they working well?
Well, it works. Sometimes it works. At least up to 3 to 4 days it works very well.
Being in Bhubaneswar,
Ah.
we see we are heated up like anything. All around there is a rainbow. Okay.
Up to 3 days, I think it is better. Otherwise, there is a problem.
Navo?
Yes, I saw your picture. This stubble burning is an issue in Punjab and Haryana. Why not in the other places? Because it shows very clearly that it is happening only in Punjab and Haryana.
Because of this season, exclusively for pertaining to this season, because they want to quickly burn this residue so that they can go to the
But
wheat.
that's
wheat
true for
quickly.
the other places also, right?
They
It's a
may not be
question of
in the
how
large
many
scale.
crops in a year you want.
No,
If
I
you
mean,
want,
They
for
may not
Bengal,
be
I know
doing-
certainly
They
similar.
may not be burning this kind of large scale burning. They may not be doing. This is also large scale, also in a short period, very short period, huge quantity. Because they have to, by November they have to go for wheat. We only told them it's a Punjab Haryana is water stress area. We only told the farmers you start rice also now. So now we are saying that why you are doing rice and this is creating problem. So
Okay, I have another stupid question probably. When we expect the next ice age to come?
pardon?
Next ice age?
Ice age, not tomorrow.
No. You see, I'm asking some question because of different reason. So I was looking into this migration out of Africa, etc., and there people are talking about this kind of fluctuation before the ice age. So I don't know.
not in our lifetimes. Thank you.